Hello there, I'm Mr. Math Guy, and today we're going to be taking a look at a 10-minute video on the area problem. Let's take a look at why we even have this problem called the area problem, and you could take a look at this figure that I have right here. In geometry, we learned the area of formulas for certain polygons like rectangles, a equals base times height, or triangles, a equals 1/2 base times height, or circles. But we didn't learn any figures such as this. There's no formulas for finding the area of something that looks like this. We would call this the area underneath the curve. So how then do we do this? Well, that is the area problem. And in this video, we're going to take a look how to estimate or to approximate the area under the graph of a certain function. So to review really quickly in geometry, probably something that you're very familiar with, the area of a rectangle. Area of a rectangle is A equals BH, or the base times the height. And you say, well, this thing is not a rectangle. No, it's not, but we're going to use the idea of finding the area of rectangles, plural, and adding them together to figure out an estimate or an approximate answer for the area underneath this curve. So here's what I mean. If we take a look at this curve, this area underneath this curve, and let's say that we start over here on the left end, okay, and it goes up to here from the left end, and we partition this into equal subintervals. So this thing is 8 units long, so if I split it up into 2 equal parts, so 1, 2, 3, 4, and I come over 1, 2, 3, 4, and I go down from there, then I have a rectangle. It is 4 units long, and it is count 1, 2, 3, 3 units high. So base times height, so this area of this rectangle is 12 units. Now, if I do the same thing, and I start again with this left end, so the left end, oh, there it is up the curve. You want to try to get it right on a value that you can see of this curve. So here, I can go over 1, 2, 3, 4, and I have another rectangle, and its width is also 4, but its height is 1, 2, 3, 4, 5. Its height is 5, so 4 times 5 is 20. So the area of this one is 12, and the area of that one is 20. So 12 plus 20 is equal to 32. So an approximate answer to the area underneath this curve is 32 square units. Now you might be saying, yeah, but you're missing a lot. You're missing all this area here, you're missing this area here, and you actually added some in here that's not underneath the area of the curve. Yeah, I know, but this is still at least an approximate answer. It's better than not knowing anything at all. So we would say, as I divided this up into 2 subintervals, and I like to write from the left end because I started to the left, and I split it up into 2 subintervals, I got an approximate answer of 32, and obviously it's squared units. Area is always measured in square units. Now, let's take a look at the same thing, except let's divide it and look at it from the right end. Now, just to write up there, from the left end, 2 subintervals, I got 32. Now let's take a look at the right end. So if I start from the right end of this graph and go from here and go over 1, 2, 3, 4, then I have this rectangle, right? And we know that this rectangle is a 4, and this time it's 1, 2, 3, 4, 5, 6. This was 6, so this area of this rectangle is 24. Now, obviously, I've got more than I need, all right, because all of this is outside the area underneath this curve. And then I go from here, right end again, so here it's on the curve, and I go over 4, and I come down. And so this one is also 4, and it's 1, 2, 3, 4, 5. It's 5 units high, and so it would be 20 square units. So 20 plus 24 is 44. So from my right end, using 2 subintervals, I got an area of approximately 44. Now, we're getting close. because if you think about it, this left end was short. The estimation was a little low because we missed some area. This one, however, is an overestimate because we have some area that we calculated that's not underneath the curve. So this one is a little too high. So we know then our answer must be somewhere in between 32 and 44. Now, we don't have an exact answer, but we at least have an approximate answer. Now, let's continue to push this forward. All right, so we have from the left end, we found 32, and that was an underestimate, and it was not enough. We found from the right end, we had 44, and that was a little bit too much. So what can we do? Because it's still, that's a difference of 8 there. That could be big. We want to try to get better than that. So what we're going to do is we're going to partition this up into more subintervals. Last time we just partitioned it into 2 subintervals. This time let's go into 4 subintervals. So if I start from the left end and I go over this time just 2 and go down. And then from the left end I just go 2 and go down. From the left end I go 2 and I go down. And then from the left end, which would just be right here, because you got to start where that curve is, and go over. Now, all of these are 2, so I partition it up into 4 subintervals this time instead of just 2. This is 1, 2, 3, 3 units high, so this part is 6. This one's 1, 2, 3, 4, so that one's 8. This one's 1, 2, 3, 4, 5, so that one's 10. And this one's 1, 2, 3, 4, and so that one's 8. So 6 plus 8 is 14. 14 plus 10 is 24. And 24 plus 8 is 32. So I got the same 32 again. And he's like, well, that didn't really help me that much. No, it didn't. All right. But what's going to help me is, see, I'm missing all this area. And I actually got a little more right here that I shouldn't have. But as I do this, as I divide this up into more subintervals, I should get closer and closer to an approximate answer. Now, let's take a look at the same thing from the right side. So from the right side, I start, right side go over just 2. Right side go over just 2. Right side go over just 2. And right side go over just 2. So each of these are 2 units long, the width. This is 1, 2, 3, 4, 5, 6, so that's total 12. 1, 2, 3, 4, so that one's 8. 1, 2, 3, 4, 5, so that one's 10. And 1, 2, 3, 4, so that one's 8. And 8 plus 10 is 18, plus 8 is 16, plus 12 is 28. I think I got that right. 16, 26, 38. So this time I got 38 from the right end, 4 subintervals. I got 38. So previously, from the left ends of 2 and 4, I both got 32. And from the right end, I believe I got 40 something. This time, I can't remember what it was. This time I have 38. So this is a better approximation. What we're going to try to show you here is the more times I split this up in more subintervals, and then I compare, I'm going to get closer and closer to the actual value of the area underneath this curve. So if I were to split this up into 8 subintervals, all right? So I'll just show you real quick. If I go 1, and then 2, and then 3, and then 4, and I do all this all the way down, 5, 6, 7, 8, then I'm going to get closer and closer to the actual area. So look for more on the area problem in other videos. Thanks for watching. God bless.